Now, let's see here, screen sharing. We'll share this screen, share, present to everybody. So my assumption is that this is the screen I'm sharing. Go in and open this PowerPoint here real quick. Well, that's a big PowerPoint. Put these on a storage drive. Hurry up and wait. Got to download, huh? It's like music. So let me open that up. Let me quickly go back into here. Let's look at sharing. We'll reshare that screen right there. Edit anyway. And we'll hope that that's what's being shared. We'll see. If not, I'll use the Collaborate software. It says it's sharing. New technology. Got to learn how to use it. So computer hardware. There's some redundancy here for sure. We've already discussed binary. Yes. So understand, computers only understand two things, two states, 1 and 0, on, off, true, false, all the other combinations of logic. We understand that it's called a bit, short for binary digit, and that 8 bits is a byte. What is 4 bits? A nibble. Okay. So how does a computer present data? Well, pretty simply, the data is input some way into a computer. Now, primarily, still today, one of the primary inputs for data into a computer is the keyboard, right? The mouse, do we tend to input data using the mouse? That's not inputting data. It tends to be how we use the computer. Okay, so to execute a program, to start up a browser, to click on a link. So it tends to be what we can do, or to do things with the computer to make it simple. So everything's converted. We've talked about this idea of a kilobyte, right? Number of bytes, 1024, megabyte, gigabyte, and terabyte. And we know that 1024 kilobytes is a megabyte, 1024 megabytes is a gigabyte, etc. And how much space we need. Well, it used to be we didn't store a lot of things on computers. Now instead of having a record collection, you have a collection of MP3s. Would we all agree? How many people still buy CDs? Why?
Sometimes. For my car.
For your car. Okay, because your car doesn't have an MP3 player. Great. So that makes sense if you want to listen to music in the car, right? I'm now to the point where I have a USB drive that connects to my car's computer, and that computer has an MP3 player in it, and it goes and it finds all the MP3 files and even gives me a list by artist and by song, and but I've told you it all reboots way too often, right? So, certainly, I remember when the idea of storage, I'll give you an example of this. When I was managing a network, we were running out of storage. So I had to buy a new hard drive for the server, because this was the server that all the people who worked at the company stored their information on. Okay. It was a thing called a SCSI hard drive, which is just different than the hard drives you all know. A 10 gigabyte SCSI drive was $1,300 for 10 gigabytes. And when we put that in, the idea was we would never fill it. But what happened to Word documents that used to be kilobytes in size? They're now megabytes in size. Why? Because we're adding pictures, we're adding color, we're adding multiple fonts. In some cases, folks, when we hit Unit 2, you're going to see an Excel spreadsheet that has videos embedded in it. That's a big spreadsheet, right? even though the video is not really part of the file, you're just accessing a YouTube video through Excel. Why? So that you can have the video on one screen and do the work on the same screen. Okay, but these files have gotten bigger. We're creating hyperlinks to other documents that now need to be associated. So computer components, two main categories, the idea of what is an input device and what is an output device. Okay, so peripheral devices, keyboards, mice, printers, monitors, display screens. Today the LCD screen, right? On my phone, 65,000 colors. Who would have ever thought? I remember when my first cell phone, had a screen that was either black or not, right? And then came the yellow. Wow, that was cool, and then multicolor. So peripheral devices with your computer must be connected to the computer by using ports or expansion slots on the motherboard. Okay, so we looked at a basic motherboard, and we'll look at one again Thursday. Give me an example of a port that you would use to connect something to your computer. USB port, okay? So it's a connector, okay? And the cool thing about USB is what they're called plug and play. So the idea was when we plug something into a USB, the computer said, hey, I might even go as far as to recognize that that's an HP Model 2520 printer. And the operating system now has within it, this is one of the reasons why the operating system has grown so big, it has some default drivers for common peripheral devices that we connect. For example, today when I walked in and I plugged in my microphone, did I then have to install a driver? No, this computer recognized this microphone. Is it utilizing the exact model, Audio Technica AT2020? No. It's using just a microphone driver that works with this one. Okay. So this is why the operating system, some of you may remember when you could actually get an operating system that fit on a CD, the whole operating system. What does the operating system come on today? Anybody know? Well, today you download it and it's 3.5, 4 gigs in size. That might still fit on a DVD today, right? But is it going to fit on a CD? No. So you Mac users, what's a standard port on a Mac today? How would you connect a device to your Mac? Huh? USB is also on Mac. But does Mac have a proprietary port? Micro USB. Those are both multi-compatible. It's not a proprietary standard. Yeah.
Is it the lightning port?
Lightning bolt or Thunderbolt?
Oh, like for the iPhone charger?
Yep. Right? So that's proprietary. So high speed. Okay? It's a high speed port that's Apple specific. Okay? USB, again, standard. We had USB 2.0. And now we have USB 3.0. Okay, here's the thing. Theoretically, when we were talking about USB, I want you all to Google this for me. What is the speed of USB 2.0? So someone go out and Google that. What is the speed of USB 2.0? .480 megabits per second. That's pretty fast, isn't it? Well, let's see how much faster. Someone now Google, what is the speed of USB 3.0?
640.
Nope. That's USB version 2. 5 gigabits per second. So remember megabits, then gigabits. So now we're talking, we went from 480 megabits to 5 gigabits per second. What does that mean? Well, that means that I can transfer a large file, let's say a movie, in under a minute. So 5 gigs in size. And those just continue to get faster. So back to Apple for a minute. Apple utilized Firewire, okay, which is an IEEE standard. IEEE is the engineering body that creates standards for computing, okay? So developed by Apple as a high-speed method for connecting multimedia devices such as video cameras to a computer. However, Firewire never took off on the PC side. It tended to be proprietary. But we did see devices that came out that could either connect via USB or Firewire, okay? So we don't see Firewire much because, as you all mentioned, it's been replaced by the Thunderbolt technology, okay? So USB or Firewire ports, other ports on the computer, so audio ports. Today, some of you might remember the 1/4-inch audio jack, okay? That plugged into the stereo, so that you could have your speakers. Today, what do we have? What's the size today that's used? What? Is it 3.5? Referred to as the 1/8-inch jack. So the idea is it's that little jack. We see it on computers. It's the small little, connector in the front. It's the same size that we use on our iPads, on our tablets, and even on our phones, right? So an RJ45 connector, which is on your homework, we call it an Ethernet connector, okay? Connects a computer to a wired network using an Ethernet cable. Now, how many people remember dial-up and the phone jack? Remember when we actually had a phone jack? Okay. Well, that was an RJ11. And depending on the phone system, it either had 2 wires or 4. Okay. All an RJ45 is a bigger, it looks like a phone jack. Okay. We'll look at one Thursday. It has 8 wires. So the cool thing is today, when we talk about connecting a phone, we can actually do what's called voice over IP, which means we can take our voice and transfer it into packets, digitize it, and send our voice over the same lines that we're sending data. And we can do it all with one cable. So in my office, I have a cable that plugs in just like a phone cable, trying to make this simple. It then plugs into my phone, which is voice over IP. It comes out of my phone and plugs into my computer. So both my voice and my data are carried over the same line. Okay? Whether I'm accessing the internet or talking with someone over Skype, it's all going over that. Other standard, ports. So when we talk about connecting our monitor still tends to be our primary output device for a computer. Okay. Would it work for audio? No. What's the primary output device if we want to listen to something? Speakers of some sort. Okay. So, but connecting the output today, this has changed. It used to be a 15-pin VGA connector. It looked blue, right? And then what happened is we wanted to digitize that to create a higher definition picture, and we went to a DVI, a digital video interface. Those are white, normally in color. And now we have HDMI, okay? So this time out for this class, I've had to change some of those definitions that you're going to get because there's new technology. HDMI happens to be one. Where do we see HDMI? TV, gaming consoles, right? High definition multimedia interface. And it's the standard interface. Okay? So, we see that on the back of our DVRs. There's even a connector to connect this directly to an HDMI. Why? Because that's the standard. So today when we buy a computer monitor or a computer, there may be an HDMI out to an HDMI monitor. Because today the televisions that we're buying are monitors. And they're smart computers. Right? Today in like a Samsung Smart TV is an operating system that has a specific version of, say, Netflix. I don't need anything else except to plug the Ethernet cable into the back of my television, which is a computer. Okay? So understanding the difference, because certainly you don't want to buy a computer to find out it has a VGA port, which you probably wouldn't find anymore anyway, as the primary output. On my brand new laptop, there is no VGA port. There is no DVI port. It's HDMI. So if I want to connect my laptop, say, to a larger screen, I do that through an HDMI. So there's some examples of, this computer has both an old technology, VGA, and the new technology, HDMI. It's got a Firewire port. Here's those audio ports that we talked about, usually 2. One for audio in, that would be a microphone. One for audio out, that's going to be speakers or, earphones or whatever the case may be. It used to be that we would add a big expansion card, audio card, to get things like 5.1 surround sound. Who needed 5.1 surround sound on their computer? Well, I did, because I was watching movies on my computer. So expansion slots, these we tend to find on a desktop computer. Okay. The idea behind expansion slots is we can add additional technology. So let me give you an example. A standard expansion slot, if I have an old desktop and it came with USB 2.0, if the motherboard supported it, I could put in an expansion card that would give it USB 3.0. So I could actually utilize new technology without having to replace the whole computer. Okay. Now, you don't see this as much. It used to be really prevalent that when new technology came out, it came out on an expansion card and you stuck it into the computer because computers were expensive. But what do you do today when your computer breaks? You just go buy a new one. When the printer breaks, what do? Buy a new one. Because the technology has gotten so affordable that tends to be the cheaper way to go. Okay. And manufacturers know this. That's why they're giving us less functionality to do things like expanding computers. Would you ever go into a laptop that you've bought and put in a new video card? No, you'd buy a new laptop with the current video technology. So expansion slots, here's an oldie but goodie. So this plugs into a slot in a laptop. It was called a PCMC-IA slot. And this was the slot that was used for the first time to do things like add a wireless. So you had a laptop and it didn't have wireless. Can you imagine that? Can you imagine having a laptop that didn't have a wireless network interface card? You actually had to plug it in. That's nuts. That's when you had the big Ethernet cable, that you would plug into the modem and then walk it through two rooms in the house so that you could sit where you wanted to sit and use your computer. Amazing. So the first network interface card, laptops did not have a way to connect to corporate networks when they were first developed. Okay. And this company by the name of Zercom was one of the first developers of a network interface card to where a user did not have to have a laptop computer that they traveled with and a desktop computer that they worked with at the office. Okay. My aunt's first portable computer when she worked for a company called Western Digital was 85 pounds. That was a portable computer. She took it with her as she traveled. The side came off. It had a little screen in it. And the piece that came off was the keyboard. It's like 80 pounds, you know. It explains why she can drive the ball 300 yards on a golf. I'm kidding, on a golf course. Interesting side story. So the company that created the first network interface card for laptops, my uncle actually was involved in that company called Zircom. So that's what their company did. They designed the first network interface card. So expansion slots. So a USB adapter connects a computer with a USB port to a device that doesn't have a USB plug, such as an older printer. So we actually had an adapter that went from an old connector to USB, and all it did was transfer that signal from one technology, one bus, to another. Okay, so some of you may have seen that, you know, back in the day when a laptop only had maybe 1 or 2 USB ports, you could buy a USB hub so that you could connect multiple devices so that you had access to all of those devices at once. Okay. By the way, today, if you want a hub, make sure you buy a USB 3.0 hub, because you'll still find the old 2.0 hubs. Those are like $9, you know, but for $29, you get the latest technology. Do you think a USB 2.0 hub supports the 3.0 technology? No. So the nice thing about USB is we can also daisy chain devices. Okay, so we can have up to 255 devices connected to one computer at a time. Who would ever need that? But you know, back in the day, before all-in-ones, does anybody know what an all-in-one is? What is an all-in-one? Yeah. Well, there's 2 all-in-ones. There's an all-in-one computer, and then there's what we refer to as an all-in-one peripheral. I'm talking about the all-in-one peripheral device. Yeah. It's a printer, a scanner, and a fax, and a copier. And today, they tend to be both a flatbed scanner, so we can put bigger pictures on, as well as a sheet feed scanner, so we can scan multiple copies at once. Okay. So how many of you still keep, when you get bills and you pay it, you write on the bill and then you have the paper? How many still keep the paper? I can't raise my hand. What do the rest of you do? Email? Keep a copy up on email? The e-version on your account? Yep. Statements in PDF, right? You go out to the bank, you download statements. Maybe a lot of people now expect the bank to keep that stuff for them. You know, what I do, I scan it all into my computer and I shred the document. Am I successful at that every week? No. Sometimes the stack gets big, but I scan it all in. It goes into, here's where a folder structure becomes important, because I don't go and rename everything that I scan in. I just let the scanner give it a name. And then the cool thing is the program I use will turn that into a searchable document. So if I'm looking for the January Ben broadband, if that document said January and Ben broadband, it'll give me that document. So an input device, again, you know, other things, of course, a keyboard is an input device. You could think of a mouse as an input device because we're clicking, giving commands. What are some other input devices that we might use with a computer? Anyone? A microphone. Wow, amazing. A microphone. Yes. What other kind of input devices today? What about on my smartphone? Anybody know, besides this being the home button, what else this button can do? It's a fingerprint reader. That's an input device. Biometrics, right? Is it real reliable? No. So people aren't really using it yet. But when it is, isn't that great security? Because think about it. Even if I leave my phone here, is there stuff on my phone I don't want people to see? You know, private messages, texts, whatever the case may be? Absolutely. You know, I might have my bank account number on my phone. Or I might have done something silly like saved my bank, username and password on my phone because it's convenient now to get into my account, right? Just hit and go. But imagine if I could literally use this reliably and scan my fingerprint as a means of getting into my phone. You know, by the way, if you don't have some sort of code on your phone, you're just asking for trouble. Because if I have a code, someone needs to at least guess the code to get into my phone. Any other input devices you can think about? Microphone, keyboard, mouse, headphones? Headphones that have a microphone, yeah. But headphones would be more of an output, listening to music. What about that magic box up there on the ceiling? Is that an input or an output device? It's a projector. It's an output device. Okay, it's a way we can output. So we've talked about keyboards, great. You know, two types of keyboards, you know, the standard QWERTY. Now a lot of people are getting into the whole ergonomic keyboard. Okay, they used to be really popular. They're starting to come back in popularity because they've been better designed. The idea that our hands are not designed to be this way, right? They're designed to be this way, so I split the keyboard. Okay. There are other keyboards, you know, definitely foldable, flexible keyboards. There at one point was the opportunity, shouldn't say an opportunity, there were some companies that were working on the idea of a proximity keyboard. So basically it was a laser that gave you an image of a keyboard on any surface, and when you touched the proximity of where the G key would be, it would sense that and type a G. But why didn't this technology ever come to play? Because this just kept getting cheaper and cheaper and cheaper. When this breaks, what do? Do you try to fix it anymore? No. You know what we used to do when these got dirty? Stick them in the dishwasher. Stick them in the dishwasher, then blow them out, let them dry for a few days, and all the sticky keys would disappear. Now it's so cheap, you throw them away. How many people will admit they have a missing key on their laptop? Great. Give me the model for $8. We can replace it. Cool. So hopefully it's not a key you use all the time. It most likely is, because that's why it's missing, right? So pointing devices, you know, input today, an input device. The touch screen is an input device for computers. Whether it's my phone, whether it's the touch screen on my computer, etc. Touchpads, so the idea of, you know, an alternative to carrying around a mouse. Touch screens. Here's an old technology. Don't learn this. But how many people remember when the keyboard came with a little blue or red, you know, that was actually a pointing stick. You could actually use your finger. It was designed for you to use your thumb so that you didn't have to take your fingers off of the home key. Use your thumb or your pointer finger. Did anybody ever really use that? No, because the technology was poor. It just didn't work real well, you know. So, but it was a way to move that cursor. So trackballs, you know, the inverted old mouse. So trackballs, really designed for ergonomics. Okay. So let's talk about, and then of course, touchscreens. Let's talk about how touchscreens and how mice work. Okay. So sort of getting away from the idea, I hate being glued to this thing. Let me remember if I always get this wrong. Is this X or is this X?
That's X.
This is X and this is Y, right? And this is plus and plus, and this is plus minus, this is minus minus, and this is minus plus, if I remember. Something like that. Hey, this is not math, okay? Don't hold me to this. This is how a mouse works, okay? It works off this grid. We know that each of these is given, if we think of these as pixels, each one is given a location, correct? So when we put down the mouse, It's telling the computer, hey, if I'm moving in the upper right, I'm moving positive X, positive Y. If I pick the mouse up and put it back down, it starts at that 0, 0 point. Cool? How do you think a touch screen works?
Same way.
Same way. Where am I touching? Oh, I'm touching over here in the positive quadrant at plus 10, you know, and plus 15. Oh, well, what's on the underside of that? Oh, a shortcut icon. So you must be wanting to press that shortcut icon. Then the question is, did I press it once so I could hold it and move it, or did I tap on it, as in double clicking, right? See a lot of touch screens these days. Digital pens is another input device, so a stylus. We're seeing that come back in the Samsung Note. You know, here's the funny thing. Most of you young people think, how cool is this? I got a way to write on my screen. It's been around since the first PDA. The Palm Pilot came with a pen, and you actually wrote on a section of the screen that took input. And you programmed it, or I should say, it programmed you on how to write an A. So if you wanted an A, that was an A. If you wanted a capital A, you pressed a button that said, do it caps and an A. And then if you wanted a B, and if you wanted a C, and if you wanted an E, let's see, you went like that. So it's been around for a while. Has the technology gotten better? Yeah, now it's more handwriting recognition. Okay. So you don't have to learn this crazy way of doing things. But a stylus, if you've ever seen digital artists, they use what's called a Wacom tablet, and they have a digital pen, and they're actually, you know, creating arts of work. Arts of work? Where did that come from? Work of art digitally on the computer. You know. So audio input devices, again, voice recognition. You know, a microphone is an audio input device. There's a microphone in my phone. It's used for me to actually talk to people, as well as to do voice recognition for texts. You know. Are you kidding me? Smiley face. And the smiley face doesn't type smiley face, right? It turns into an emoticon because that's what it's been programmed to do. Other input, video is an input now. You know, FaceTime, Skype, it's an input. It's bringing communication back into computing. Other input devices, so joysticks or, you know, controllers, you know, for those of you that are gamers, all input devices. I mean, if you think about it, an Xbox controller is nothing but a bunch of controllers that give XY coordinates to the computer. You know, where is my car pointed? What speed is it supposed to be going at in the video game, etc. You know, am I doing a jump shot or a free throw or whatever the case may be? Scanners as input devices. So, you know, utilizing barcodes, USB barcodes. You know, shopping today is fun. I just go into the store and I say, hey, wonder what this costs online. Click. And if I'm in Best Buy, I walk up to the front and I say, hey, Best Buy, Amazon has it for this. And what do they say? We'll price match. You know, because they want you to buy it in the store. Speaking of FaceTime. So flatbed scanners, barcode scanners, and then, of course, RFID. Now, RFID was something that we expected to see a lot of. And it hasn't come to fruition because of the expense of creating RFID readers and RFID chips. Okay? So radio frequency identification. Now, where do we see this used a lot? In shipping. Okay? We see it used a lot in high dollar shipping, where it's worthwhile and cost effective to put an RFID chip either embed it or put it on a packaging so that we can follow that package, follow that box, and know where it's going. Yep, tracking. Okay. So a way of tracking. I actually, boy, it's been over a decade ago. There was this idea of opening up a water park in Redmond next to the Deschutes County Fairgrounds, an indoor water park with a hotel and a bunch of other stuff. And the idea was, wouldn't it be amazing if we could create an RFID cost-effective, we were thinking the technology would get there, where everyone who came in would get an RFID bracelet, and we could then follow them around the facility, know where you stopped, know if an RFID, here's where the safety came in. If an RFID being worn by a certain age, like a child, stopped at the bottom of the pool for upwards of 20 seconds, it would notify the lifeguard, who may not be able to see the bottom of the pool because the pool's filled with kids, but know that there's a kid or an RFID bracelet that's fallen off of a child sitting at the bottom of the deal. Is that really why we did it? No. It's because we're following the Disneyland model. Folks, Disneyland knows where you are pretty much the whole time. How? Because you all use the Fast Pass. You all go to a touch screen, you slide your card that they give you, which is now your ticket, right? And you pick a Fast Pass, and they know that you're going to come back to that ride. How do they know if you came back to that ride? Because you scan your Fast Pass to get on the Fast Pass line. Do you think Disney wants to know where to put those churro carts? Do you ever wonder why those churro carts are mobile? So that they can move them because they know where the crowds are going to be at certain times of the day. And if they put a $5 churro cart in front of me at Disneyland, they're going to make $100 in 3 days because I'm going to eat the heck out of churros. It's when I can get them at Costco for $1, right? It's weird. It is. So wireless scanners, magnetic scanners, all come into play. We have till what, 1220? Okay, just checking. Optical character recognition. So this is the idea that I can take that printed document that's given to me, I put it into my computer, I scan it into my computer, and it goes through a computer process that knows, hey, this representation of dots that I've scanned, because scanners work on dots per inch. Okay, the more dots per inch, the higher the quality. What do LCD monitors work on? Not on dots, but what do we call each of those picture elements? A pixel. The more pixels we have, both horizontally and vertically, the better the what? The better the resolution, the better the picture. You bet. So the idea here is I can scan that. It looks at dots and says, hey, that dot pattern looks like an R. So I'll convert that into an R so that it's editable. Editable. Say that 5 times fast. Scantrons, biometrics, you see all this stuff in movies. It does exist, but it's expensive. That's why we all don't have a retinal scanner for our phone. But wouldn't that be awesome security for your phone?
Well, that's why they said the fingerprint.
Exactly. Although it's so unreliable, most people don't use it. They're still using a code, It is better. The technology continues to get better. I had a laptop 8 years ago that had a fingerprint reader on it, and it worked fairly well. The problem was you needed to be someone with an IT degree to figure out how to make it work. You have to enter it perfectly. You also have to remember to enter multiple fingers. Talk about learning the hard way. So this is the finger I use the most, my pointer finger. So I had a swipe scan of my finger. And then what did I do? I burnt my finger. And I'm like, oh, I can't scan on my computer. That's okay, because I also have a password. Take me to the password screen. Well, it's been, It was only a month or so. Do you think I remembered the password that I haven't used in a month? No. So I'm trying to break into my, what's my password? What did I set that for? Luckily, I had done something really foolish and written it down. Not on the bottom of the computer, by the way. So output devices, display devices, LCD, pretty standard. You know, LCD screens. I'll have one that Thursday that I've taken apart. It might amaze you how little there is to an LCD screen. Also provide a video that you might want to watch, an optional video on how an LCD screen works. It is amazing technology. So screen resolution and size, there we go. We talked about pixels. The more pixels per inch, the better the quality. You know, screen resolution is expressed in, you know, we hear this term all the time, right? When we go to buy a television now, we're either dealing with 720p or what? 1080. Do you know what the P is? Progressive scanning over interlace scanning. 1080i, 1080p. Don't worry, we'll talk about it. The video card is what runs all that. And if you remember last time, we talked about the video card literally being its own independent computer. Designed and developed to do what? Process video. To get those pixels the right color as quickly as possible so that we see the clarity that we do. Screen resolution and size. You know, it used to be that these were 480 pixels wide. You know, now what are they? You know, y'all maybe remember, you know, 1024, right? By 768 as a resolution. Now we're up at 1900 by 1300. Projectors, great output device. Digital light processing, printers, pretty standard output device that we think about. And an all-in-one is something that would do printing, copying. They still put a fax machine in there. I don't get that. Because I don't know about y'all, but I'll just scan it into PDF and then email it to someone. Imagine asking somebody today, hey, can I fax you something? You know. You had to fax something last week. Well, I actually had to fax something to the state a year ago. I got audited for the child care credit or whatever. I guess it's been a few years ago now. And I just scanned in the PDFs here and got them in an email. And I called the state and I said, okay, I'm ready for my audit. Who do I email this to? Email it? You can't email it. You have to fax it. I have to fax it. And they're like, yeah, you fax it. And then what happens is it comes over the fax and then someone here will scan it into the person who's doing your audit. Wait a minute, I already have it scanned. Why don't I just send? Well, this is how the process works, right? Our tax dollars at work. What's that? Oh, yeah. It's amazing. Let's come into the 21st century and save some money so that we can give veterans better health care. Oh, I feel like I'm running for president. Y'all vote for me. Should be great. It's me versus Donald Trump. So printers, you know, it used to be, I remember, you know, home printers that you would start a print job and you went and had dinner and you came back and it printed a really cool black and white page. Right? Now you sit there and you watch it spit out a photo quality photo in 15 seconds. You know, and the all-in-one printer maybe cost you $125, right? At Costco. You know, they're still getting us on the ink though, aren't they? That printer ink is just expensive. Oh yeah, where you get the monthly subscription. Yeah. So, yep, inkjet printers or laser jet printers. So an inkjet printer, you know, jets the ink onto the page, you know, like spitting it, right? A laser jet uses toner, puts the toner and then lasers it onto the page. Okay. There's also another type of printer that you tend to see in grocery stores. Does anybody know what it's called? It's a thermal printer. So the paper is specially developed. We apply heat to where we want to put a character, and it works. So here's what you do. Next time you go to the store, take one of those receipts, okay, and throw it on your dashboard for a day. Yeah, and it gets dark because you're applying heat to the entire page. So you'll see the thermal, reaction there. Another way to do it, I guess y'all are college students. I wouldn't recommend this to the kids when I'm teaching them basics. Just put a lighter underneath the paper. Not to where you burn it, but, to where the heat, and you'll watch it blacken. Why thermal paper? Cheaper than having to have the toner or the ink. Yeah. And do they print a bunch of receipts? Yes. So specialized printers, you know what? I think this is where we'll stop today. We'll talk about labels and plotters and all that good stuff. There's the thermal. And yes, mobile printers. I'm hoping to get in. I think I might have told you all. Let me go ahead and stop my sharing and stop my broadcast here. And I'll